In this video, we're going to determine whether a given number is a zero of a function. So our first problem says to determine if -4 is a zero of the given function. Well, what does it mean to be a zero? Well, algebraically, it means that if I put that number, in this case -4, into our function, I get out 0. So in other words, is f of -4 equals 0? And I can solve this problem 4 different ways. One way is just to evaluate the function, put -4 in place of x, and I see that f of -4 is equal to 18. So it doesn't equal 0, so it's not a zero of the function. The next way that I can determine the answer is by using the remainder theorem. And without going into too much detail about why it works this way, is that when you divide, is your remainder 0? Well, I'm going to do synthetic division here with my 0. My coefficients are 1, 8, 8, and -14. Bring down the 1, multiply, add, multiply, add, multiply, add. And this 18 right here is my remainder. So f of -4 is equal to 18. It doesn't equal 0, so it's not a zero. Now the next two methods require me to put my equation into my graphing calculator, and then I can either look at the table or look at the graph. In my table, I can see that if I put in -4, I get out 18. And in my graph, I can see that -4 is not a zero. In order for this to be a zero, my graph would have to cross the x-axis at -4, and it doesn't. Problem 2, I'm asked to determine if 1 plus 2i is a zero of the polynomial. And again, there's a couple of different ways that I can do this problem. One is to evaluate my function at 1 plus 2i. So when I evaluate the function, I get 0. So is this number a zero? The answer is yes. Now another way to do this problem is to use the remainder theorem. That means I'm going to be using synthetic division. And when I write down that first row of numbers, I want to spread them out as far as I can. Bring down that first number, get 1 plus 2i here. So add, I get -1 plus 2i. Now when I multiply what's below the line, -1 plus 2i, times what's in the box, 1 plus 2i, I want to be sure that both of those numbers are in parentheses when I put it in my calculator. So I have 0 for my remainder. That means f of 1 plus 2i is equal to 0. So this is a zero of my function. Because I'm dealing with an imaginary number, I know that my graph is not going to help me. It's not going to show up as an x-intercept. So using my table or my graph is not going to help me on this particular problem. And I want to remind you how to put your calculator into the mode to be working with non-real numbers. Hit the mode button that's up near the top of your calculator, right next to the blue second button. Just going to hit mode, and I'm going to scroll down near the bottom. You can see right now I'm in the mode that's allowing me to work just with real numbers. I want to scroll over to select a plus bi, press enter to be sure that that is highlighted, and then we can quit. Second, quit. Now if I wanted to type in an imaginary number, let's say a complex number of 3 plus 4i, to get to that I button, it's a second function button right above my decimal. So I need to hit second and then the decimal. That will get me to the I. And then I'll close my parentheses. And let's go ahead and multiply this by 4 minus 2i. Be sure that both of those numbers are in parentheses when you multiply, and press enter and you'll get your answer.